Hi, I am Lopamudrashen. Welcome back to my channel Electronic Science Tutorial. I will start a new lecture series on NTA UGC NET and West Bengal SET exam for Electronic Science subject. Those who are not follow my channel, please follow my channel. If you like my channel, then please like, share and subscribe my channel. So let's start our class. In today's class, we discuss about the NTA UGC NET and West Bengal SET exam 2022. In this session, we cover in detail about this topic so that we can easily solve the previous year question paper of UGC NET Electronic Science. Each and every topic we can understand in easy and simple manner. So, let's begin our NTA UGC NET exam 2022 class. Okay. Today I will talk about next important topic of semiconductor diode, that is PN junction under reverse bias condition. In previous class we already talked about PN junction under no bias and under forward bias condition. Today I will discuss about the PN junction under reverse bias condition. Reverse bias condition means when the P side of the diode is connected with the negative potential of the power supply and the N side of the diode is connected with the positive potential of the power supply, we can say that diode is in reverse bias condition. Okay, so this is the structure of the PN junction under reverse bias condition. This side is P side and this side is N side. In P side, the electrons are the minority carriers and the holes are the majority carriers, and in the N side, electrons are the majority carriers and holes are the minority carriers. So, when this is called reverse bias, the P side is connected with the negative potential of the power supply and the N side is connected with the positive potential of the power supply, and this condition is called reverse bias condition. Okay. So, external potential of V is applied across the PN junction. The positive terminal is connected to the N-type material and the negative terminal is connected to the P-type material. The number of uncovered positive ions in the depletion region of the N-type material will increase due to the large number of free electrons to the positive potential of the applied voltage. So electrons are attracted in this potential because electrons are negatively charged and the potential is, and this terminal is connected with the positive potential. So electrons is attracted in this terminal and holes are attracted in this terminal. Holes are positively charged and this terminal is connected with the negative potential. So holes are attracted with the negative potential of the power supply. So what does it mean? It means the net effect therefore is a widening of depletion region. Okay. This widened depletion region will establish to create a barrier for the majority carriers to overcome, effectively reducing the majority carrier flow to zero. Electrons are repelled through the junction towards the positive potential of the power supply, and holes are also repelling from the junction and attracted towards the negative potential of the power supply. So the depletion region is widened, and the majority carrier of the holes and the electrons on the p side and the n side does not overcome this widened depletion region, and that's why we get the majority carrier flow is 0. Okay, so this is the condition under reverse bias. The current that exists under reverse bias condition is called the reverse saturation current, and it is due to the minority carrier flow. The reverse saturation current is a few microampere range. Okay, the term saturation comes from the fact that it reaches its maximum level quickly and does not change significantly with the increase in the reverse bias potential. The reverse bias condition, so this is the reverse bias condition, and in this way, or this is the basic concept of reverse bias condition of PN junction. Okay, and this is the energy band diagram of reverse bias condition of PN junction. So what we know, if we apply a potential between the P and N region, we will no longer be an equilibrium condition. In equilibrium or in thermal equilibrium condition, the Fermi energy level is constant throughout the system. But when we apply a voltage between the P and N region, the equilibrium condition is break. The Fermi energy level will no longer be constant throughout the system. Right? So this is the energy band diagram of the PN junction for the case when a positive voltage is applied to the N region with respect to the P region. As the positive potential is downward, the Fermi level on the N side, that means EFN, is below the Fermi level on the P side. So in this case, the Fermi level of the N side is below on the Fermi level of the P side, and the difference between the two is equal to the applied voltage. Right? So this is the EVA or QVA, applied reverse bias voltage. Right? So this is the energy band diagram of PN junction under reverse bias condition. Thank you. I hope you understand this topic. I will stop here. Okay. With this, we have come to the end of our session. I hope you like this video. Thank you, friends. If you like my video, then please do like, share and subscribe my channel. फिर मिलते हैं एक नई वीडियो के साथ. Thank you.